Lesson 6.2 is about inverses and contrapositives. Okay, this is a little chart that we set up to help you understand the relationship between the four types of conditional statements. Now, the two in the top row, a statement and its converse, you already know about this. This is an if-then statement. If I make the if-then statement, if P, then Q. Now, if the hypothesis is true, then the conclusion must follow. Well, the converse of that, you already know, is I just switch the Q and the P. The hypothesis and conclusion get switched, so I have if Q, then P. Well, the next statement we're going to learn about is called the inverse. And the inverse, if I look vertically across the chart, the inverse negates the original statement. Where I have if P, then Q, the inverse of that adds the word not. If not P, then not Q. So the same with the converse and the contrapositive. The contrapositive is a statement that negates the converse. Where the converse is if Q, then P, the contrapositive adds the word not. If not Q, then not P. So if I look across this chart or down, up and down this chart vertically, I find that vertically the statements at the bottom negate the converse and the statement at the top. So vertically, I negate. If I look left to right across the rows, I switch P and Q. So horizontally, if I'm constructing this chart, I switch P and Q. Now, the last thing you need to know is that a statement and its contrapositive, if I look vertically across the chart, are what we call logically equivalent. So I'm going to put LE. Logically equivalent means either both of those statements are true or they're both false. So a statement and the contrapositive are logically equivalent. That also goes for the inverse and the converse. They're either both true or both false. So the inverse and the converse diagonally across from each other are also logically equivalent. Okay, now this really doesn't make that much sense until we use it with examples. So let's do that. Okay, for this example, let's say that my original statement is a true statement. If you live in California, if you live in San Francisco, then you live in California. So that would be a true statement. Okay, the converse of that is I switch the hypothesis and the conclusion, and I say, if you live in California, then you live in San Francisco. Well, clearly that's not true. You could live in Danville or Walnut Creek or Los Angeles. So this was false. So a statement and its converse can be, one can be true and one can be false. Okay, now let's go to the inverse. Remember, the inverse negates the original statement. The original statement, if you live in San Francisco, then you live in California. So we negate that. If you don't live in San Francisco, then you don't live in California. Well, that's not true. Once again, you could live anywhere in California outside of San Francisco. You could live in Sacramento, and you would, be living still in California. So this statement is false. Notice it's the same as the converse in terms of being true or false. Those will either both, the converse and inverse will either both be true or both false. Now on to the contrapositive. When the contrapositive negates the converse, it says, if not Q, then not P. So if I don't live in California, then I don't live in San Francisco. Well, that's true. If you're not living in California, you can't be living in San Francisco. So notice that that is logically equivalent to the original statement. Again, those are either both true or both false. So that's just a little example, and now we'll apply it once again. Okay, sometimes a Venn diagram can be helpful in constructing how to look at statements, how to evaluate statements based on a conditional. So what we do is, like if I'm looking at the prior statement we were talking about, if you live in San Francisco, then you live in California, what we can do is we can put the P, the hypothesis, the if, in the smaller circle in the diagram, and put the Q, the conclusion, in the larger circle. And that makes it easier for us to test statements and see, to draw conclusions. So let's do an example. Number one, let's say we know that Ryan lives in San Francisco. Well, can I make a conclusion about that? Yes, I can, because I can say, well, Ryan lives in California, because if he lives in San Francisco, then he lives in California. Okay, so for the second statement, Bailey lives in California. Can I make a conclusion based on San Francisco and California about Bailey? Well, I really can't, because Bailey could live somewhere out here in California. She could live in Danville, or she could live in San Francisco. I don't know. I don't have enough information. So I really can't draw a conclusion for number two. Okay, statement number three. Max does not live in San Francisco. So Max does not live in San Francisco. Can I draw a conclusion about whether he lives in California or not? Well, Max could live in some other city in California, or Max could live out of state. Max could live in Nebraska. We don't know. All we know is he doesn't live in San Francisco. So with that statement, really, we cannot draw a conclusion. Okay, and then for the last example, Snooky does not live in California. Now, can I draw a conclusion about her residence in San Francisco? Well, yes, I can. If Snooky does not live in California, she's out here, and I can draw a conclusion that she definitely does not live in San Francisco. So I think what we're seeing here is that statements and the contrapositives of statements are always either both true or both false, and converses and inverses represented in example 2 and 3 are either both true or both false. And I think that the way to get better at this is just to go through lots of practice exercises in class and on your homework, and draw. I really recommend drawing the little Venn diagram and helping sort things out. So that's the end of the lesson.